Thomas Edison, often called the Wizard of Menlo Park, was a prolific inventor who revolutionized modern life. His most famous invention, the practical electric light bulb, literally illuminated the world. But this was just one of his many contributions. Edison's genius lay not just in his inventions, but in his approach to innovation. He established the world's first industrial research laboratory, pioneering the concept of organized, systematic invention. This approach transformed invention from a solitary pursuit into a collaborative, industrial process. Beyond the light bulb, Edison's inventions included the phonograph, motion picture camera, and improvements to the telegraph and telephone. His work on electricity distribution systems laid the foundation for modern power grids. Edison's relentless work ethic and his famous quote, "Genius is 1% inspiration and 99% perspiration," continue to inspire inventors and entrepreneurs today. His legacy reminds us that innovation often comes from persistent experimentation and a willingness to learn from failure. Nikola Tesla, a visionary inventor and engineer, was a pioneer in the field of electricity and magnetism. His work laid the foundation for our modern alternating current AC electrical system, which powers homes and businesses worldwide. Tesla's brilliant mind conceived ideas far ahead of his time. He invented the AC motor, developed the Tesla coil for wireless transmission of electrical energy, and contributed to the development of radio technology. His concept of wireless power distribution, though unrealized in his lifetime, foreshadowed today's wireless charging technologies. What sets Tesla apart was his ability to visualize complex machines in his mind, often building them without drawings. His work was driven by a desire to harness nature's forces for the benefit of humanity. Despite his numerous contributions, Tesla died in relative obscurity. However, his legacy has experienced a resurgence in recent years, with his name adorning electric cars and his status as a cult icon of geek culture. Tesla's life serves as a reminder of the power of imagination and the sometimes unpredictable path of recognition in scientific advancement.
Click subscribe to this channel to get more topics you love.
Alexander Graham Bell. Alexander Graham Bell is best known as the inventor of the telephone, a device that fundamentally changed human communication. However, his inventive spirit extended far beyond this single achievement, encompassing work in areas as diverse as aviation, hydrofoils, and assistive technologies for the deaf. Bell's invention of the telephone in 1876 was born from his work in sound and speech. As a teacher of the deaf, including his wife Mabel, Bell was deeply interested in the nature of sound and its transmission. This background gave him unique insights that led to the telephone's creation. But beyond the telephone, Bell's curiosity drove him to explore various fields. He made significant contributions to aviation, including the development of the tetrahedral kite. He also worked on early metal detectors and helped develop the photophone, a precursor to fiber optic communication systems. Bell's life exemplifies how a deep understanding in one area can lead to groundbreaking innovations in others, and how a spirit of relentless curiosity can fuel a lifetime of invention. Leonardo da Vinci, the quintessential Renaissance man, was an inventor far ahead of his time. His notebooks reveal designs for flying machines, armored vehicles, and even robots, concepts that wouldn't be realized for centuries. What made Leonardo unique was his approach to understanding the world. He combined keen observation of nature with an unparalleled artistic skill and a deep curiosity about how things worked. This interdisciplinary approach allowed him to make connections others missed, leading to innovative designs. While many of Leonardo's inventions remained theoretical, his work laid important groundwork for future innovations. His studies of human anatomy informed his mechanical designs, his understanding of optics improved his art, and his observations of birds influenced his flying machine designs. Leonardo's life teaches us the value of crossing disciplinary boundaries and the power of combining art and science. His legacy continues to inspire inventors and artists alike, reminding us that creativity and analytical thinking are not opposites, but complementary tools for understanding and shaping our world. Marie Curie, a pioneering physicist and chemist, revolutionized our understanding of radioactivity and discovered two new elements. Her work not only advanced science but also paved the way for groundbreaking medical treatments. Curie's most famous achievement was the discovery of the elements polonium and radium. This work required processing tons of pitchblende ore, a task she undertook in a shed with rudimentary equipment, demonstrating her remarkable dedication and perseverance. Beyond her discoveries, Curie's legacy lies in her approach to science. She was committed to the idea that scientific knowledge should benefit humanity, applying her research to develop mobile X-ray units for use in World War I field hospitals. As the first woman to win a Nobel Prize and the only person to win Nobel Prizes in two scientific fields, Curie broke barriers for women in science. Her life illustrates how scientific pursuit can be driven by a desire to understand nature and to improve human life, and how determination can overcome societal obstacles. Johannes Gutenberg's invention of the movable type printing press in the 15th century sparked a revolution in the spread of knowledge, laying the groundwork for the Renaissance, the scientific revolution, and the modern age. Gutenberg's genius lay in combining existing technologies, the wine press, paper, oil-based ink, and movable type into a system that made the mass production of books possible. This dramatically reduced the cost and time required to produce books, making written knowledge accessible to a much wider audience. The impact of Gutenberg's invention was profound and far-reaching. It standardized and preserved knowledge, accelerated the spread of ideas, and contributed to the rise of literacy. The printing press played a crucial role in major societal shifts, from the Protestant Reformation to the rise of modern science and democracy. Gutenberg's innovation demonstrates how combining existing elements in new ways can lead to transformative inventions, and how technologies that democratize information can reshape society. James Watt, a Scottish inventor and mechanical engineer, is best known for his improvements to the steam engine, which became a driving force behind the Industrial Revolution. His work transformed not just technology, but the very fabric of society. Watt's key innovation was the addition of a separate condenser to the steam engine, dramatically improving its efficiency and power. This seemingly simple change had far-reaching consequences, making steam power practical for a wide range of industrial applications. Watt's engine powered factories, mills, and eventually locomotives and ships, revolutionizing manufacturing, transportation, and commerce. Beyond the steam engine, Watt made other significant contributions. He invented the concept of horsepower, developed a copying machine for documents, and created a parallel motion mechanism crucial for many machines. Watt's life illustrates how enhancing an existing technology can have transformative effects, and how engineering solutions can reshape economies and societies. His legacy lives on in the watt, the unit of power named in his honor, reminding us of the enduring impact of his work. Wright brothers Orville and Wilbur. The Wright brothers, Orville and Wilbur, achieved one of humanity's oldest dreams: powered, controlled flight. Their success on December 17, 1903, near Kitty Hawk, North Carolina, marked the beginning of the aviation age. What set the Wrights apart was their systematic approach to solving the problem of flight. They studied birds, conducted wind tunnel experiments, and developed their own data on lift and drag. Crucially, they recognized that control was as important as lift, leading to their innovative three-axis control system still used in aircraft today. The brothers' work went beyond just getting a machine into the air. They continued to improve their designs, turning the airplane from a fragile experimental device into a practical means of transportation. Their invention opened up new possibilities for travel, commerce, and unfortunately, warfare. The Wright brothers' story is one of persistence, methodical problem-solving, and the power of collaboration. Their achievement reminds us that even the most seemingly impossible challenges can be overcome with patience, careful study, and innovative thinking. Tim Berners-Lee. Tim Berners-Lee invented the World Wide Web, a system that has transformed how we access information, communicate, and conduct business. His creation has become so integral to modern life that it's hard to imagine a world without it. Berners-Lee's breakthrough came from recognizing the potential of linking hypertext with the Internet. While working at CERN, he developed the first web browser and server, as well as the protocols HTTP, HTML that form the backbone of the web. Crucially, he insisted that these technologies remain open and free, allowing the web to grow organically. What sets Berners-Lee apart is not just his initial invention, but his ongoing efforts to shape the web's development. He has been a strong advocate for net neutrality and the idea of the web as an open platform for innovation and free expression. Berners-Lee's work illustrates how a single idea, when made freely available, can spark a revolution in human connectivity and knowledge sharing. His ongoing engagement with the technology he created serves as a model for inventors taking responsibility for the societal impact of their work. Benjamin Franklin. Benjamin Franklin was a polymath whose inventions ranged from practical household items to fundamental concepts in electricity. His creative mind and curiosity led him to make contributions in various fields, embodying the spirit of American ingenuity. Among Franklin's most famous inventions are the lightning rod, bifocal glasses, and the Franklin stove. His experiments with electricity, including his famous kite experiment, helped establish the principle of conservation of charge and led to our understanding of positive and negative electrical charges. Beyond his inventions, Franklin was a statesman, writer, and scientist who played a crucial role in American independence. His approach to invention was often driven by a desire to solve practical problems and improve daily life. Franklin's story teaches us that invention can come from keen observation of everyday challenges, and that a curious mind can find opportunities for innovation in many different fields. His legacy as both inventor and civic leader shows how scientific pursuit and public service can go hand in hand. Archimedes, the ancient Greek mathematician and inventor, made groundbreaking discoveries that continue to influence science and engineering today. His work spanned mathematics, physics, and engineering, demonstrating the power of applying theoretical knowledge to practical problems. Among Archimedes' most famous discoveries is the principle of buoyancy. Legend has it, he discovered while taking a bath. This led to his famous exclamation, "Eureka, I have found it." He also invented the Archimedes screw, a device for lifting water that's still used in some parts of the world today. In mathematics, Archimedes made significant advances in geometry, calculus, and the calculation of pi. His method of exhaustion laid the groundwork for integral calculus, developed nearly 2 millennia later. Archimedes' life teaches us the value of curiosity and the power of applying mathematical thinking to real-world problems. His work bridged the gap between theoretical mathematics and practical engineering, an approach that continues to drive innovation today. Archimedes reminds us that foundational discoveries can have impacts that last for centuries. Stephen Kwolek's invention of Kevlar, a material 5 times stronger than steel by weight, has saved countless lives and revolutionized numerous industries. Her discovery came while working on developing new fibers at DuPont, showcasing how industrial research can lead to transformative innovations. Kwolek's breakthrough came from her persistence in working with a solution that other researchers might have discarded. She recognized the unique properties of the cloudy, thin solution she had created, which, when spun into fibers, demonstrated remarkable strength. Kevlar's impact extends far beyond its most well-known use in bulletproof vests. It's used in everything from fiber optic cables to spacecraft, demonstrating how a single material's innovation can find diverse applications. Kwolek's career, during which she earned 28 patents, is particularly noteworthy given the challenges faced by women in STEM fields during her time. Her story illustrates the importance of persistence in research, the potential for unexpected discoveries, and the vast impact that materials science can have on various aspects of life and technology.